Well, hello there. Today, we're going to take the next step past confidence intervals into the hypothesis test. For this problem, we're going to look at popcorn. And so our contestants decided to test the percentages of kernels that popped from name brand versus store brand. They picked 10 bags at random from each type of popcorn. The numbers here list the percentages of kernels that popped. And so the question is, are they different? So we can look at them a little bit right now and say, they look like they're all in the 90s and 80s, but why don't we run a two-sample t-test for the difference in the means of the two? Right now, what I'd like you to do is pause the video, enter those numbers into L1 and L2, and see if you know how to run the test. But at the very least, let's get those numbers in L1 and L2. Well, okay, we're back. So we did it. We've entered the datas in L1 and L2, and now we're going to set up our hypothesis test. What I'm going to show you here is the exact method that we want you to do when solving this problem. The first thing we're going to do is identify mu1 and mu2, x bar 1, x bar 2, s1, and s2. What are they? Well, in this case, mu1 will be the average percentage of name brand popping. Okay? And then mu2 will be the average percentage of store brand popping. And so the question is, we're interested in the difference. Okay? And is there any probability that the difference will contain 0? Because if it does, then we can fail to reject, or we can reject the null hypothesis. Or we fail to reject the null hypothesis, sorry. We want to test the difference. So here we go. Our null hypothesis. Our null hypothesis is that these two are equal. In other words, 0 can be a possibility at the alpha equals 0.05 level. In other words, 95% confidence, right? Remember that? Okay, the alternative hypothesis here. Now, we're going to go ahead and assume the name brand is going to pop more than the store brand. So we're not just going to see if there's a difference. We're going to propose that this name brand has a greater percentage than the store brand. So I'm looking for a one-tail remark here. Now, what's going to happen in our calculator is our calculator is going to evaluate for us x bar sub 1 and x bar sub 2, and then s sub 1 and s sub 2. And we'll get those 4 values. And we need to show those 4 values. The next thing we're going to get is a t-value and a p-value. And then finally, well, almost finally, we're going to draw a curve. And we're going to fill that in, and then we will make our conclusion. Okay? So we've got those numbers entered into our calculator. Let's let our calculator do the work, and we're just going to interpret it. So we take out our calculators, and let's see what happens. So we've got the calculator here at the home screen. We're going to go to Stat, Edit, and let's just make sure our numbers are all entered in there, and they are. We're going to go to Stat, Tests, and let's see, do you see it there? T-test, that'd be for one sample. Oh, there it is, number 4, 2-samp t-test. Hit enter, and we notice that our information is coming from data. Again, like with the confidence interval, the default's going to be L1 minus L2. So we're going to leave that in there the way it is. This time, the alternative hypothesis is that mu sub 1 is greater than mu sub 2, right? More kernels will pop from the name brand. Pooled, no. And let's calculate. Well, there's a lot of information on that screen. Let's see what we have. We have a t-value of 2.4274. We have a p-value of 0.13. That's pretty low. Let's get our data here. So our first mean is 89.9. Our second mean is 84.5 for the store brand. Then we have our standard deviations of 5.13 for the name brand, a little bit bigger, and 4.81. Okay, now, that's basically it. Once we have this information, we're going to color in our curve and make our conclusion. But this is what you need to show. So you need to identify the 1 and the 2. Give me the null and the alternative, the 2 sample means and the 2 sample standard deviations, our t-value, so you know that this is going to be way out here at 2.43, right? This is just like the normal curve with z, right? Except we're using with t a little tighter. So 0, 2.43, and the p-value here is 0.13. Well, what is that saying? Okay, 0.013 is less than 0.05. We are going to reject the null hypothesis because what's happening here is we're saying if the null hypothesis were true, we would expect these results about 1.3% of the time. And that's low. It's not 0. But it's low and it's below 5. Now, what if I had said alpha equals 0.01 level, the 99% level? We would fail to reject. But because our p-value is less than alpha, we're going to reject the null. And that's how this works. The connection you need to be thinking about is that if we were to make a 95% confidence interval, 0 would not be on that interval. And that's the connection between confidence intervals and our 2-sample t-test. But for now, we're just going to run the 2-sample t-test. Take a good look. Here's your popcorn problem. Thanks. Keep working, keep reading, and keep washing those hands.